Soviet-era spacecraft launched about a half a century ago. It is headed back to Earth, and it is a tricky trajectory with experts expecting it to come down.
Minutes after a retired Soviet engineer revealed their story, planetary scientists and historians began to grasp the magnitude of what had been hidden for decades. For years, whispers suggested that the Soviet Venera program had captured extraordinary footage of Venus, images that were never released to the public. Now, the reality of those images was coming into focus, and it suggested that humanity may have glimpsed aspects of Venus no one was meant to see. Venus is a world of extremes. It is often called Earth's twin because it is similar in size and mass, but any similarity ends there. Its surface temperature averages over 450 degrees Celsius, hot enough to melt lead. The atmosphere is dense and suffocating, composed of 96% carbon dioxide, with clouds of sulfuric acid that rain relentlessly. Surface pressure is 92 times that of Earth, which would crush an unprotected human instantly. Winds swirl at hundreds of kilometers per hour in the upper atmosphere, and the dense clouds reflect almost all sunlight, leaving the surface in perpetual twilight. Every attempt to land a probe must account for these hostile conditions, and failure is almost guaranteed. Despite the dangers, the Soviet Union began launching probes to Venus as early as 1961. The Venera program, spanning more than 2 decades, endured repeated failure. Early missions were destroyed during launch, while others failed in orbit or burned up in the thick atmosphere. But the Soviet space program persisted, determined to reach the planet's surface. By the mid-1970s, the Venera probes achieved unprecedented milestones. Venera 9 and 10 returned the first black-and-white images of Venus's surface, revealing rocky plains and jagged formations. Venera 13 and 14, in the early 1980s, transmitted the first color images and collected soil analyses, revealing chemical compositions unlike anything on Earth. Yet even these images were carefully curated for release. Frames that could not be explained or were deemed potentially controversial remained classified. According to the retired engineer, additional footage exists, high-resolution images captured under extreme Venusian conditions, depicting the surface in ways never publicly shown. Shadows moved in unexpected ways. Glints of light appeared on surfaces that did not correspond to known minerals. Some images hinted at textures and formations that challenged even the most seasoned planetary geologists. The engineer claimed that only a handful of scientists had access to these frames, and they were considered too anomalous to release. The Soviet program faced technical and environmental challenges that would destroy most probes. Electronics melted at high temperatures, mechanical systems were crushed by extreme pressure, and cameras had to be specially shielded to survive the corrosive atmosphere. Each Venera lander was a marvel of engineering. Reinforced casings, insulated electronics, and heat-resistant lenses allowed them to operate for long enough to capture images and data. Some Venera landers survived for over 2 hours, transmitting data until their internal systems failed. This feat is remarkable when one considers that ordinary equipment would have vaporized in minutes. The footage described by the insider reportedly shows transient phenomena, shifting shadows, strange reflections, and luminescent patches across the surface. These effects could correspond to chemical reactions caused by high temperatures and pressures, or to electrical interactions in the dense atmosphere. At the time, Soviet engineers documented these anomalies but lacked explanations. The decision to withhold the footage was as much about the limits of scientific understanding as it was about secrecy. Even decades later, Venus continues to defy simple categorization. Observations from orbiting spacecraft have mapped the surface and analyzed atmospheric composition, but much remains mysterious. The Venera program, often underappreciated in the West, provided humanity with its first direct images of Venusian rock and soil. If the unreleased footage exists, it could reveal phenomena never considered in models of Venusian geology or atmospheric science. The idea that footage of Venus has been kept from the public raises questions about what we don't know and what our own assumptions have blinded us to. Every rock, shadow, and reflective surface could contain clues about processes that operate only under extreme conditions, processes that Earth-based laboratories cannot reproduce. For decades, scientists worked with the images released to the public, assuming they represented the full story. Now, for the first time, there is reason to believe the story is far more complicated and far more remarkable. The Venera landers captured more than static images. Engineers described fleeting luminescence, reflective surfaces, and shadows that moved in unexpected ways. Some surfaces appeared metallic, catching faint light from the lander's own instruments. Shadows shifted independently of known wind patterns, suggesting that localized atmospheric phenomena or chemical reactions were creating temporary optical effects. The Venera probes face near impossible odds. Venus's surface destroys unprotected electronics in minutes. Cameras were encased in heat-resistant alloys, and electronics were insulated with multiple layers to survive both pressure and heat. Yet even with these protections, some landers transmitted high-resolution images for over an hour. Each frame provides a glimpse into the planet's harsh but complex environment. The unreleased footage reportedly captures phenomena that were never interpreted or explained, hinting at active processes on the surface. Scientists have long suspected that Venus hosts dynamic chemical and electrical activity. Magellan and Venus Express provided radar mapping and electromagnetic data, revealing patterns consistent with lightning, volcanic activity, and unknown energy transfers in the atmosphere. The Venera footage could represent the first direct observation of such phenomena at the surface. Movements in shadows, flashes of light, and glints on rocks may correlate with these high-energy processes, providing clues that orbital instruments alone cannot detect. The anomalies described by the insider include patches of reflective mineral surfaces that appear to change with temperature, streaks in the soil that might indicate chemical reactions, and faint luminescence that shifts across the rocky plains. Some scientists speculate these could be the result of sulfur or metallic compounds interacting under extreme pressure. Others suggest electrical discharges akin to static sparks in Earth's storms reacting with the dense carbon dioxide atmosphere. Each of these possibilities represents a natural process, yet one that is extraordinary in its intensity and visibility. Secrecy around these images is unsurprising. The Soviet Union operated under strict control, and all data from space missions was subject to political and security oversight. Only data considered safe, interpretable, or scientifically uncontroversial was released to the public. Images that challenged understanding, hinted at unknown processes, or could spark speculation were kept classified. For decades, this meant that the public and much of the scientific community never saw the full story. Modern missions are returning renewed attention to Venus. NASA's Veritas and Da Vinci Plus missions, along with ESA's Envision, will map the surface and atmosphere in unprecedented detail. Radar will probe beneath the thick clouds, while spectroscopy will reveal the chemical composition of the soil and atmosphere. If the unreleased Venera footage exists, it could provide context to these modern observations, giving scientists the only direct visual perspective from the surface at the extreme conditions where chemistry, geology, and atmospheric science intersect. The engineering triumph of Venera is a story in itself. Each lander survived temperatures, pressures, and corrosive environments that would have destroyed conventional electronics. Cameras transmitted images through dense clouds and extreme heat. Spectrometers analyzed soil under crushing pressure, and atmospheric sensors recorded chemical composition. The fact that any images survived, let alone high-resolution footage, is a testament to human ingenuity and persistence. Footage captured under these conditions represents more than just static images. It is a record of processes occurring on a living planet. Rocks that glow, shadows that shift, and reflective surfaces may hint at chemical and electrical processes never fully understood. For decades, scientists assumed Venus was static, a geological graveyard. The insider's account suggests that the planet may be far more dynamic, with processes unfolding in real time, hidden from view until now. The existence of unreleased Venera footage raises profound questions about what we have yet to understand about Venus. Were these anomalies merely difficult to explain chemical reactions, or did the Soviets witness surface phenomena that challenged the models of planetary science itself? The reported anomalies, luminescence, reflective surfaces, shifting shadows, suggest processes far more complex than previously assumed. Venus has long been considered Earth's twin gone wrong. Decades later, observations from orbiting spacecraft continue to reveal the planet's mysteries. Magellan mapped volcanoes, plains, and mountain ranges. Venus Express detected electrical and atmospheric anomalies that defied easy interpretation. The unreleased footage, captured directly from the surface, could explain these mysteries, providing context for phenomena that orbiters cannot detect from above. The secrecy of the footage also illustrates the tension between science and politics. Decisions about what data to release can shape the public understanding of a planet for decades. The Venera program may have captured the first hints of phenomena on Venus that were deemed too unusual to release, leaving humanity with only partial knowledge. Future missions, including NASA's Veritas, Da Vinci Plus, and ESA's Envision, are preparing to study Venus in unprecedented detail. But the Venera footage represents something unique: direct observation under conditions no modern probe has yet survived. If analyzed, it may reveal chemical, electrical, or geological processes previously unknown, and perhaps even overturn assumptions about the planet's stability and composition. Venus is no longer just Earth's hostile twin. It may be a dynamic, active world with processes that are still largely invisible to us. The insider's revelation reminds us that exploration often uncovers more questions than answers. For decades, humanity believed it had a full picture of Venus. Now, there is reason to believe that the planet still holds secrets captured on film decades ago and only now coming to light. The Venera missions demonstrated the resilience of human technology and ingenuity, but they also hinted at phenomena far beyond our understanding. Glows, reflections, shifting shadows, all captured in a world so extreme that conventional science struggles to explain them, serve as a reminder that the solar system still holds mysteries beyond imagination. And now, for the first time, those mysteries may finally be revealed.